Hello, okay, so we're going to continue with lesson 10.4, and this time we're going to discuss parallel lines and perpendicular lines. Okay, and so we're basically going to be able to identify and draw parallel lines and perpendicular lines by the time we're done with this lesson. So unlock the problem, and we're on page 411. You can find models of lines in the world around you. For example, two streets that cross each other model intersecting lines. The metal rails on a train track that never cross, those model parallel lines. So there's three more terms that we need to add to our list of glossary terms, geometric terms, or make flashcards out of them using index cards. And so one of the terms is intersecting lines. So what are intersecting lines? Intersecting lines are lines in a plane, two-dimensional plane, that cross at exactly one point. Intersecting lines form four angles. Okay, so here we see two lines, HI and JK, and they cross at this point right here in the middle. So we read this as line HI intersects line JK at point X. And this is how we would write it. Line HI and line JK intersect at point X. So now let's look at some things. It says that two intersecting lines form four angles. So there's one of them. The second angle. The third angle. And the fourth angle. We can outline the angles. That's 1, 2, 3, 4. Okay, we also need to know parallel lines. Parallel lines are lines in a plane that are always the same distance apart. Parallel lines never intersect. So here we have two lines, line DE and line FG, and they're going in the same directions, and they're the same distance apart all the way across the line. So no matter how far I extend this line, it's always going to be the same distance apart. So we read this as line DE is parallel to line FG. And our symbols for that would be line DE, the parallel line symbol, FG. Line FG. And the symbol means is parallel to. So line DE is parallel to line FG. Perpendicular lines. All right, so perpendicular lines are lines in a plane that intersect, but they form four right angles. In this first one, these are just intersecting lines because none of the angles that were formed made right angles. But now when we look here, this is a right angle, that's a right angle, that's a right angle, and this is a right angle. So it makes four right angles. And so we read this as line LM is perpendicular to line NO. The symbol for that would be the line LM. This is the symbol for perpendicular to line NO. All right. One helpful thing that might help you remember parallel lines versus perpendicular lines, the word parallel itself has a set of parallel lines. The L's in parallel are parallel to each other. Okay. All right. So tell how the streets appear to be related, right? Perpendicular, parallel, or intersecting. West 36th Street and Broadway. West 36th Street and Broadway. So here's West 36th Street, and it crosses Broadway. Okay, so there's just that word crosses means it can't be parallel. Okay, so those are not parallel lines. So it's either intersecting or perpendicular. Now, do these two streets form right angles? Well, all right. So right there, I'm lined up with 36th Street. If Broadway was perpendicular to it, it would form a right angle. Broadway would be right over here. So this is not perpendicular. It is intersecting. How about West 35th Street and 7th Avenue? West 35th and 7th Avenue. West 35th, 7th Avenue. All right. So if we put 36th Street even with that, and we draw that in, we notice that it runs exactly at a right angle to it. So that is perpendicular and intersecting. So if the lines are intersecting and they form right angles, we give it two names, intersecting and perpendicular. If it's intersecting and doesn't form right angles, we just say it's intersecting. And the last one, West 37th Street and West 36th Street. Well, 37th Street is here, 36th Street is here, and they're not going to cross. So those are parallel lines. All right, 412. All right, so you need something to draw a straight edge with. A ruler is great, but anything that you can make straight lines with. All right, so our activity, draw and label ray, that's the symbol for ray, YX, perpendicular to ray YZ, intersecting at point Y. Okay, so that symbol means perpendicular to. So step one, let's draw ray X, YX. And so they've started that for us. Right? Okay, so Y, X, and now draw and label YZ. It's perpendicular. So if it's perpendicular, it has to form a right angle. So angle Y, ray YZ. Okay. Make sure Y and Z intersect at point Y. Yes, they do intersect at point Y. That's where they touch. Make sure the rays are perpendicular. They are. They form right angles. So how can you check to see if two rays are perpendicular? You can use a square corner. So that's what I was doing with this. I was confirming that it was going to be a right angle. Now name the figure you drew. Well, what did we draw? What is this? Well, we made an angle, and you can call it ZYX or angle XYZ or angle Y. Can we classify the figure? Yeah. Angle ZYX is a right angle. It forms a square corner. Two rays that are perpendicular must form a right angle. Okay, they're not perpendicular if they don't form right angles. Okay, so draw and label line segment QR parallel to line segment ST. All right, so line segment QR. All right, QR, and ST is parallel to it. So that means it's not going to cross it. There is to that. All right, now looking at the figure, name two line segments that appear to be parallel. Well, there's a couple possibilities here because I see that CD is parallel to BF. So line segment CD is parallel to line segment BF. Or I can look at it this way and use those line segments. So I could have line segment CB parallel to line segment DF. Okay. Name two line segments that appear to be perpendicular. So again, perpendicular means we're going to form right angles. So if I have line segment CB, what forms a right angle with it? Line segment CD. I could have line segment CD perpendicular to DF. I could have line segment DF be perpendicular to BF or FB. I could have line segment FB perpendicular to CB or BC. So, and that makes sense. A rectangle has 4 right angles. So I should have 4 sides that are perpendicular to each other. Okay. Number 4, name a pair of lines that are perpendicular. So we're looking for something that forms a right angle. Pair of lines. Well, there's a huge clue right there that the intersection point of these two forms right angles. So they're perpendicular. So I can say line FJ is perpendicular. Line FJ is perpendicular to HG. Name a pair of lines that appear to be parallel. Well, when I look at that line and that line, regardless of how far you extend the lines, they look like they will never cross each other. So I'm going to say line CD is parallel to line JF. Remember this, we can name this line 2 different ways. We call this line FJ or JF. We can name this line as DC or CD. All right, draw and label the figure described. Line segment RS parallel to line segment TU. All right, so that means the 2 lines will not cross each other, correct? So let's draw 2 line segments. They don't have to be the same length. We know that it has 2 definite endpoints. So call this R and S, call this T and U. All right. 7. Ray, KL. Okay, so Ray, KL, Ray, KM. Okay, so that would form a right angle. Okay, how do I know that? Well, because the K is the endpoint of both these rays. It doesn't have to be a right angle. It just, that's what I drew. It could be any angle. Okay, it doesn't show us that it's perpendicular, but also doesn't say it's not perpendicular. All right, CD is perpendicular to DE. Okay, so this time we do have to have right angles. So line segment CD is perpendicular to line segment DE. Put the little right angle symbol in there. All right, JK, line JK is perpendicular to line LM. Well, it doesn't tell me where they intersect. Okay, so we just have to name the different lines. So this can be JK, and this can be LM. So it forms 4 right angles. All right, line ST intersecting UV at point X. All right, so it says intersecting, so it's not, doesn't have to form right angles, it's not perpendicular. And it intersects at point X. So now we just need to name our lines. S, T. Okay, so this is line ST. We'll call this line UV, and they intersect at point X. Number 11. Line AB is parallel to line FG. Line AB is parallel to line FG. All right, use the figure for numbers 12 through 13. Dan says line HL, let's highlight that, line HL is parallel to IM. Is Dan correct? Well, here's a situation where right now they're not touching, but if you were to extend the line out into space, because remember, a line goes on in both directions, continuously in both directions. So I can use a straight edge to extend the line out. You will notice that they would intersect right there. So if they cross, how can they be parallel? So no, he's not correct. No. The lines will intersect. So they can't be parallel. All right. Name 2 intersecting line segments that are not perpendicular. Line segments. Well, let's say KL. What intersects KL? Well, GK does. Those lines are not perpendicular. They don't form a right angle. So we could call it that. So there's some different possibilities. We could even go with the 2 they gave us to start. In the previous problem, HL and IM, those 2 lines are going to intersect. I'm sorry, not IM. LM is what I meant to say, because it's a line segment. It can't be this one, okay? Because the line segment wouldn't continue on, okay? But LM, HL would not cross, would do intersect. GK and KL intersect. All right, so 2 intersecting line segments, GK and KL. All right, 414. What geometric terms describe a corner of the living room? Corner of the living room. So what is that? Well, I could say it's a right angle or perpendicular line segment. Because perpendicular line segments have to form right angles. Name 3 parts of the plan that show line segments. Okay, well, that's a symbol on a map, on a house plan would be a door. So the kitchen door, a wall in the dining room, maybe the wall here in the bathroom, wall. Okay, so there's multiple ways of different line segments here. So just choose 3 different parts, make sure you describe them. Name a pair of line segments that appear to be parallel. Well, okay, so the left and right walls of the dining room. So what I'm talking about here on the left and the right side of the dining room, these line segments are opposite of each other. So they are parallel. And do not intersect. All right, so again, you could take the 2 walls of the kitchen that are opposite each other that do not intersect. You could take 2 walls of the living room that are opposite each other that do not intersect. The living room actually has 2 pairs, right? 2 pairs of lines that are parallel, and so on. All right, name a street that appears to be parallel to 17th Street. Okay, so let's find 17th Street. Okay, so 17th Street's running this way. I want a street that also runs that way. Well, 18th does, 19th does, 20th does. So, there are multiple possibilities. 18th Street, 19th Street, or 20th Street are parallel to 17th. Name a street that appears to be parallel to Vernon Street. All right, so Vernon Street's running left to right. So Perry Street runs the same direction. So Perry Street is parallel to Vernon. Name a street that appears to be perpendicular to 19th Street. So we want something that's going to form a right angle with 19th Street. Okay, so here's 19th Street. Oops. All right, so this edge of my paper represents 19th Street, and I want a street that runs this direction. So that could be Chestnut or Austin. Both of those would form right angles. So Chestnut Street or Austin Street are perpendicular to 19th. Choose the labels to make a true statement. Okay, so we're looking for perpendicular. Line GH is not perpendicular to anything. So it's not GH. IJ. Okay, IJ is perpendicular to two lines. IJ is perpendicular to BA or AB. Okay, or IJ is perpendicular to CD. Okay, well, that's not an option then, because this side doesn't have those. Okay, so I'm going to cross that out. Line AB is perpendicular to IJ, or AB is perpendicular to EF. Okay, there it is. Okay. And GH wasn't perpendicular to anything. And all these other ones are lines, and then that's a line segment. Line segment AE. Well, that's AE. So, all right, so line AB is perpendicular to line EF. All right, so in our next lesson, we're going to be talking about classifying quadrilaterals. We talked about that in third grade. So this should be a review in our next lesson. So until then, may the numbers always be